Hi, I'm Sage.
I'm Praj,
And
and this is Space Synth.
So Space Synth is exactly what it sounds like. We're using spatial information to create sound using synthesizers. So the right hand and the left hand and the forehead are three different body parts that we're tracking with LEDs, and information from those, such as X position, Y position, depth, separation distance between the two hands in one dimension, are controlling a bunch of different parameters to our music generation, such as amplitude, frequency, wave shape. So two synthesizers, and we also have a low frequency oscillator, which we can control the amplitude and frequency of.
The primary audio generating components of our system are the two subtractive synthesizers. Each of these synthesizers consists of two oscillators, one mixer, one amplitude controller, and one IAR low-pass filter. Both oscillators in each synthesizer can be configured to generate an audio waveform with a specified frequency, amplitude, and wave shape, which is selectable between a sine wave, a square wave, a triangle wave, and a sawtooth wave. In practice, the user only has direct control over the frequency of oscillator 1. The frequency of oscillator 2 is instead tuned to a specified number of octaves above or below that of oscillator 1. The user controls the frequency input to both synthesizers using the horizontal position of both of their hands. For example, the frequency input to synthesizer 1 is controlled by the horizontal position of this red LED. Moving the red LED to the left-hand side of the screen lowers the pitch, and moving the LED to the right-hand side of the screen increases the pitch. Let's take a listen to what this sounds like. There are two possible amplitude levels for each synthesizer, which is controlled by the vertical position of each hand. For example, moving this red LED to the bottom half of the screen makes the output of synthesizer 1 quieter, and moving it to the top of the screen makes it louder. Similar to the operation of this red LED, the horizontal and vertical position of this green LED controls the frequency and amplitude of synthesizer 2. The horizontal distance between both hands controls the cutoff frequency for the low-pass filters. Bringing the hands closer together lowers the cutoff frequency, thus eliminating more high-frequency components and making the sound softer. A separate low-frequency oscillator, abbreviated LFO, can be enabled to modulate the frequencies of both synthesizers. This adds a lot of varieties to the sounds the system is capable of producing. The LFO is controlled by the proximity of both hands to the camera. Bringing the red LED close to the camera increases the frequency of the LFO, or the rate at which the modulation happens. Bringing the green LED close to the camera increases the depth of the modulation, or how much the frequency is changed within the cycles of the LFO. Finally, changing the waveforms of the different oscillators affects the timbre of the sound. To simplify the process of selecting these, we've created 3 presets with different combinations of wave shapes for each of the 4 main oscillators. Moving the blue LED between the 3 sections allows the user to select between one of these 3 presets.
So the way we are tracking the limbs of whoever's using this is by using LEDs, and we cover them with socks just to reduce some shadows and dampen the light a little bit. But we hold them up to the camera, and the camera is reading in the pixels serial and handing them over to us serially, and we are taking those pixels and converting them to HSV values from RGB, because that's a little more robust to some lighting changes, and then we're passing that through to some color thresholding or chroma keying that helps us classify the pixels as red, green, or blue, or none of the above. And once we do that, we hand it off to a center finding module, which tracks the center of the LEDs as well as the area just by accumulating the pixels over the course of one frame. And we also store the processed pixels into BRAM, where we then later pull them out of BRAM when we're displaying them on the VGA at 65 megahertz. So the VGA over here will show the actual LEDs. So you can see this is the green being tracked, and the crosshairs are tracking the center, and here's red. And there are also some other visuals at the bottom which just show how the location, area, separation are affecting the different synth controls. So like we mentioned, the left hand controls the first synthesizer, the right hand controls the second synthesizer, and we also have an option to control the wave shapes, combinations of wave shapes of some of these different oscillators, and that's the blue LED that is worn on the head. So showing all three, there's the blue, and the yellow bars will determine, just by tilting your head, you can see which region it falls in, and there's 3 different regions for 3 different combinations of wave shape. So, for example, switching over to the wave shape on the right, so this is what the display looks like when we have multiple LEDs on there simultaneously. So the leftmost screen tracks the red LED, and that's just displaying the mask from the chroma keying. And the right-hand screen tracks the green LED, the middle screen tracks the blue, which I don't have right now. Notice for the red, my red shirt is not being picked up, so it's pretty robust to noise. And even with a little bit of noise, it's doing a pretty decent job of tracking the center. Responds pretty fast. This is the full range of distance that you can move, and you're also welcome to dance.